Welcome to Universe Chat. What if I tell you that an obstacle in front of mankind to explore space is not just technology, but distance too? You heard me right. Even if you find an exotic, habitable exoplanet near Earth, it would nearly take us 1,000 years to travel. And traveling to another galaxy seems impossible. But there's one more interesting thing that I think you guys should know. That nature has made its own interesting ways to shorten distance, dilate time, and help us reach the unreachable, untouchable, great dark horizons of space. Today, we will dive deep into the universe and have a look at one of the most mysterious things, wormholes. Joining me are two experts, Dr. Dia and Dr. Farhan. Thank you guys for joining me. So, starting with the basics, what are wormholes?
Thanks, Maria. Well, they are not imagination, but they come from mathematical solutions of Einstein's equations. That's why scientists even call them Einstein-Rosen bridges. So these equations were very complex, and when scientists solved them, they found unexpected results.
Einstein-Rosen bridges. Where does the name drive from?
Well, in 1935, Einstein, along with another physicist named Nathan Rosen, found a solution that two points in space-time could be connected to each other through a bridge. They called them Einstein-Rosen bridges, which are now referred to as wormholes.
So, I'm sure the bridge term has been interpreted in different words. What does the practical term actually mean?
It basically suggests that the space could be bent so much that two distant points could be connected. It's basically like folding a piece of paper and creating a hole in between to create the shortcut between the two points.
Well, the wormhole theory postulates that a theoretical passageway could be created between two points that could connect the points together. Now, instead of traveling across the whole universe, we could just jump in between the wormholes to travel through those points.
That's impressive. That leads me to my biggest questions. Do wormholes theoretically exist?
Yeah, when very massive objects exist in space, they bend the space around them. So the massive the object is, the stronger is the bending force. When an extremely massive object exists in space, its bending force becomes so intense that not even light can pass through it. This is what we call a black hole. So scientists believe that when gravity becomes this strong, no other force can hold the object together. So it basically collapses in the black hole.
You can imagine this as one end of a wormhole. Now, a question arises here is that could this bending be so extreme that it could be able to connect to another point in the space-time? Well, to answer this, yes. Theoretically, it is possible, and when that happens, wormholes are made.
So we do have a proof that they're out there.
Not quite. So this is the point to ponder on. We do have substantial amount of evidence on the existence of black holes, but there's still no wormhole found.
So I think we have discussed quite a lot of benefits, but I'm pretty sure that you guys also encountered some flaws and challenges. What was the biggest challenge that you faced?
Well, one of the most important problems is the size. Wormholes are predicted to be of very microscopic levels, around 10 raised to the power negative 33 centimeters.
That's incredibly small. So are these wormholes big enough to for large spaces and planets to travel through?
Yes, theoretically they could be that big because as the universe expands, it is possible that some may have stretched to that large size. And such matter has only been observed in behaviors of certain vacuum states of the quantum field.
What makes them unstable?
Well, for a wormhole to hold a size that big that it can let pass a spaceship or a planet through itself would require enormous amounts of exotic matter with dark energy to keep the tunnel stable. One of the physicists, Stephen Su, said that these exotic matters are nowhere to be found in the universe. They do not exist in the universe. The matter that could hold the wormholes together to make them stable, that doesn't exist.
Could you explain what exotic matter is?
Exotic matter. This should not be confused with antimatter or dark matter. Exotic matter is a term used in physics to describe forms of matter that behave very differently from the ordinary matter we're familiar with, like atoms, molecules, and everything we can see around us. What makes exotic matter exotic is that it can have unusual properties that don't normally occur in everyday conditions, especially when it comes to energy and gravity. One of the most important ideas linked to exotic matter is something called negative energy density. In normal matter, energy is always positive. It adds to gravitational attraction, but exotic matter in theory could have negative energy, which means it would create a kind of repulsive gravity. Instead of pulling things together, it would push them apart. This concept is important in advanced physics theories, especially those involving space time. It is important to note that exotic matter is still mostly theoretical. Scientists have found large stable amounts of it and may not even exist in unstable form. But it plays a key role in helping physicists explore the limits of our understanding of the universe, especially in areas like quantum mechanics and general relativity. So, in simple, exotic matter is a type of matter with unusual properties, especially negative energy, that could, in theory, allow for incredible phenomena like wormhole.
Let's assume we stabilize one. Are there any other dangers inside?
Yes, definitely. With this, here comes our third problem. There is the radiation dangers inside the wormhole. Space is full of high energy particles called cosmic rays, and when we talk about wormholes in particular, these cosmic rays, these particles are trapped and even focused more due to the bending of the curvature of space time. So, physicists like Kip Thorne have identified these radiations as a massive buildup, massive obstacle.
Last but not least, gravitational forces. The curvature of space in a wormhole would create extreme tidal forces, so anything that tries to pass through could be crushed or stretched, similar as the spaghettification effect around the wormhole.
So, we just discussed that wormholes have a lot of challenges, massive radiations, energy requirements, time paradox. Why does this research still matters?
Well, right now the universe is so huge that our fastest aircraft will take thousands of years to reach other planets, and as you said, to reach other galaxies, it seems like quite impossible, right? Basically, most of the universe is completely out of reach for us, and wormholes could completely change that. They would let us pass through points and travel across the universe in a matter of time.
Exactly. We might be able to visit distant planets, explore new worlds, and watch amazing events in space up close. This idea of wormholes reminds us that the universe may hold secrets far beyond our reach, waiting for us to discover them.
Thank you guys for joining me. I hope we're able to discover everything that seems impossible right now because science is worth knowing. Thank you.